Circles with D3. This is the thing that we're going to create, and this is the code that we're going to write. We're going to touch upon a bunch of different concepts, including the D3 general update pattern, this method chaining with D3, functions, objects, arrays, and it's all in the context of hot reloading. So you can do things like change colors and it reloads instantly. Here we have a blank slate. Opening the editor, we can see there is a readme.md markdown file that describes this viz, a package.json which specifies D3 as a dependency, and an index.js. Inside of index.js, we import select from D3. Select is the main function that we need in order to select DOM elements with D3. There's also a function exported called main, and this function expects as input a container, which is a DOM element. I'm going to make a new thing based on this blank slate. So to start, I'm going to click fork, and then I'll call it circles with D3. To create some circles, first we need an SVG element, which I can create by saying select container dot select all SVG dot data, and I'll pass an array with a single element in it dot join SVG. And if I run this with Control S or Shift Enter, it should create the SVG element. Let's see if it did by right-clicking and saying Inspect. And sure enough, there it is. Notice that the dimensions of this SVG element are 300 by 150, which you can see up there. So we need to specify the width and the height, which we can do with .attr width, and I'll pass in width and .attr height, but these are so far undefined variables. Let's define width to be container.client width, and then height can be container.client height. Client width and client height are properties of DOM elements that give you the rendered width and height on the screen of that DOM element. So if we inspect again, we can see that the dimensions are now 960 by 500. Okay, now we really have a blank canvas, an empty SVG element. Now we can make some circles. So we can say SVG dot select all circle dot data, and this is where I would like to define data that drives our circles. So I'll create a new variable here called data, and this will be an array of objects, and each of these objects can define the coordinates of a circle. So let's say x is 20, and y is 20. These are going to be pixel coordinates. Okay, we've got our data. Now we can say dot join circle, and then we can specify the attributes of this circle with .attr cx, which is the center x coordinate of the circle, and this will be a function of, I'll call it d, which is one of these objects in the data array, and it can just return d.x. So in this case, this function will return 20 because that's what x is on the first item in the data array. And similarly, we can say .attr cy is a function that returns y. Now these circles are not showing up yet because we also need to specify r, the radius. And now when I run it, I get this little circle that shows up. So now we can do things like tweak the x and y coordinates of our little circle here. And in so doing, you can see that y, a y value of 0 is at the top of this SVG. And as it increases, it goes down. And similarly with x, 0 is on the left. And then as it increases, it goes to the right. Now that all this is set up, we can easily just add some more circles here. And these will, we can move them around. And we can create kind of a, a approximation of a scatter plot pretty easily. Just create a couple more circles here. And then we can tweak the radius of all of them at the same time. Now, what if we wanted each of these to have different radii? We could add an R property to all of these, and then just say, R is also a function that returns d.r. Now we can tweak the radius of each one individually. And then we could even, make up different colors. I'll say fill is a string that is a hex code starting with hash. And I'll say FF0000, which happens to be the color red because this is an RGB color. And these first two are R of RGB, which is red, red, green, blue. If we make that 00, it's black. And if we make the second two FF, it's green. And if we make the last two FF and the middle two 00, it's blue. So that's color hex codes in a nutshell. I think I'll put this property on all these objects. And then we can add another attribute, which is fill. And now all the circles are blue. And we can actually, if you hold down Alt, you can get a color picker to change the colors of each of these circles here. So you can change the colors to your heart's content. And just for a little extra stylistic fun, we can change the background color of our SVG by saying .style background color, or maybe just background would work, and put a hex color in there. And so now we can, tweak the background color. Now there's a cool thing you can do with circles when they overlap, which is to set the opacity, .ettr opacity, let's say 0.5, and we can tweak this. We don't get much resolution on this tweaking, but if I express it as a fraction, then we can get more, finer grain manipulation. So yeah, that's how you can create circles with D3. Oh, let me go in and update this README here. I'll just say, creating circles with D3. And also, here is a challenge for you. I'd like you to fork this example by clicking this little fork icon here and modify it. Maybe make it, Halloween themed. Maybe make it Christmas themed. In any case, be creative. And you see now that renders here in the description. Okay, there's kind of a lot going on here, and it may be, too much too soon, but this is where I want to start, because this will set us up to build great things with clean code. So let me just do a recap of everything that's going on. First of all, we're inside of this function called main. the idea with the main function is that we can encapsulate whatever graphics and visualization stuff we create into this function that can easily be invoked from a variety of different contexts, such as an existing app that's maybe built with a framework like React or Vue. And by the way, if you export the code, if you click this little export button, it downloads these as files, and then you can drop them into the source directory of an existing project if you want to, and then you can just call this function. And by the way, this is all standard JavaScript ES modules. But when you invoke it, you need to pass it a container. And this code expects that the container is a div element that has a measurable height. And sometimes getting a div to be a certain height, you might need to add some CSS to specify the height. Here in VizHub, it is defined in such a way that you know that you can rely on client height. And by the way, you can change the height if you want. By default, it's 500, but you could change it to 800, and then it will adjust. But anyway, you can measure client width and client height like this, and then this chunk of code here, it uses this pattern with select all, .data, .join. And I know this is a lot to take in, but this is a pattern that we're going to see over and over and over again. This is the D3 data join, also called the D3 general update pattern. And I will be explaining it in more depth with maybe a Venn diagram in the future. But suffice it to say that this does what we want, because the first time through, it calls select all SVG, which selects all of the children of this DOM element that happen to be SVG elements. And at first, there are none. So this, selection comes up empty. And then we say .data, where we're telling D3, okay, this is the data that we have. It's going to be an array of whatever. It doesn't matter what this is at all at this point, because all we're really relying on is the length of the array being 1, because all we want is a single SVG element. And then we say .join. And by the way, this .join is actually shorthand for a more complex version of this that deals with enter as a selection. And also, it defaults to do this. Update, which will do nothing. And then exit, which by default will remove the element. And that's the case where, if the data changes length and reruns, then it will get deleted. And this more complicated syntax is really what it's doing under the hood. And you need to use this when we get into transitions, like animated transitions, which are super cool. But, as a shorthand of this, we can just say .join SVG, like that. And so the first time this code runs, it will create an SVG element, because the select all comes up empty, and there is a data element, and so then it says, okay, I have to trigger the enter case of appending an element. But then the second time through, or if I, change one of these, which triggers the hot reloading, it calls this function again and again and again. And in that case, there is already an SVG element, and so it gets picked up here. And then this .join says, okay, there is a data element, and there is a DOM element, so I don't need to do anything. I'm just going to do the update thing, which in this case it's no operation. So anyway, that's how we set up this SVG element. And by the way, calling dot, dot, dot like this. This is a pattern called method chaining, which is all over D3. And it may be kind of complicated looking, but it's a nice way of structuring the API to the library, in my opinion. And what that means is, we could break this up at any point, and maybe I should break it up and say, okay, this is the part of the code that sets up the SVG, and then we can call .ettr after the fact like this to set the width and the background, stuff like that. But these are essentially equivalent, because .attr returns the SVG selection. So we could actually say like this, and this is equivalent to the chained version, because .ettr, which sets an attribute of the DOM element, it returns the selection, and so does style, which sets the inline style of the element. And by the way, we can inspect what this does by looking at the DOM itself in the Chrome dev tools, which are super useful. We can see here that it says width equals 960. This is the HTML representation of the DOM tree. DOM means document object model, which is what this is. All HTML pages are built up of this document object model. So that's what those .attr calls do. And then there's this .style, which actually creates an inline style, which is CSS, cascading style sheets, the styling language of the web. So it's just setting the background CSS property to this color. And somehow it got transformed into this RGB syntax. I guess D3 does that internally. Yeah, so that's how we set up our singular SVG element that persists across renders. Now with data here, we define an array of objects. And each of these objects has properties: X, Y, R, and fill. This is the structure that we typically use with D3, an array of objects that has properties. And these are roughly equivalent to rows and columns of a table. So each object represents a row, and each of these properties represents a column. In the future, we're going to load in data from CSV files, comma-separated value files, and we're going to have to figure out these X and Y coordinates using D3 scales. But for now, in this simple example, it's just sort of hard-coded, the coordinates directly in pixel coordinates. So that's our data array. And then down here, we're managing these circles. So again, it's the same incantation. .select all circle, .data, .join. This is the D3 general update pattern, or the D3 data join pattern, all over again. And here we use the variant of .attr, and again, .attr is short for attribute. It sets the DOM attributes. This is the variant of attribute that accepts as a second argument a function, and that function takes as input D, which is a convention in the D3 world to refer to one of these rows of our data, or one of these data items, they're sometimes called. And again, if we want to figure out what impact this has on our DOM elements, we can just inspect these circles, and here we see the HTML representation. So CX and CY and R and fill, these are all set to be strings. So that's how that part works. That's how we manage these circles. And this editor we're using is called VizHub, which is a platform that I created to help teach my data visualization course. And if you use Alt and drag on numbers, you can change these numbers interactively. These are called interactive coding widgets, that I'm calling them. And every time it changes, it actually recompiles and reruns this code on top of the existing DOM elements. This is called hot reloading. And it's super cool. I think it's like the way of the future, because it lets you tweak things super smoothly and get this truly instant feedback inspired by Brett Victor, Inventing on Principle, classic talk. There's also this AI assist feature that I used a couple of times. Like if I get rid of this code, for example, and I start typing .ettr, and then I click AI assist, it will kind of figure out what I need and type it straight into the editor here. And this is super useful. I can't wait to start using this in the more complicated cases. All right, that's circles with D3. I look forward to see what you come up with for this challenge. Thanks for watching.